All right, good morning. How's everyone doing? Progress doing wonderful. It's almost the end of the week for us. Well, I have classes tomorrow, but we're on the downside. No classes Friday. Anyone got class Friday? Good. Oh, you do? Sorry. I did spring. Yeah, I had 5 days a week. I like having the 3 day weekend. I still work, but anyway. So we're getting into chapter 2 now. So we kind of see how the rhythm works. What's today? Today's Wednesday. I forget what day it is. Monday we had our first second day of instruction, which is a tutored math day. So you come in and that's where you work through things, ask your questions, work with each other as you need, but it's really the self-directed learning. Today we're going to go back to kind of the direct instruction. I'm going to take you through a lesson. We'll see how long it is, 30 minutes, 45, an hour, whatever we need. You'll have your chance to ask the questions. We will work through the quiz together, so you'll see 5 to 6 questions worked out. And this is also being recorded. So after I record them, they go into the chapter. So you'll see lesson 1 class lecture. I'll click here. In this page, actually, I'll get that. I'll try to organize this a little better because I've got so many different recordings. But you'll see, I'll try to make it, I'll indicate it as by the Math 141 lecture. The week before, I will have done a lecture for our Math 140. So they're about a 1 week ahead of us where we're at because they started 2 weeks early. Okay, so you may see multiple lectures. They'll be very similar. Of course, there's always a little different. And then I did a recording of what we did on Monday. It was about 15 minutes just where I introduced how the second day of instruction works, which is more active. So those are there, so you can see exactly what was in there if you missed class or if you were here but wanted to see stuff that goes on. The nice thing about the recorded, I want to just kind of emphasize, is that when you watch these, there is I'm going to turn the sound off. There is a settings. I usually go to playback speed. I'm in a graduate program myself. I finished one. I keep, as long as I get free tuition, I'll keep taking classes. I usually listen at least 1.5 to 1.75. I speak kind of slowly, so I would listen to myself sometimes at 2.0. But I did that with my professor. So you get through a lesson in half the time. And what you do is, what it does for me is it helps me to focus. If I listen at regular time, I keep drifting off because in normal speech we've got pauses and stuff, and our brain actually thinks much faster than someone can talk, and we can pick things up. But you work what works for you. You can also, when you get to the place where you need something, you can come back, you can slow it back down. So I can go to 1.75. Everything's going to happen faster, but I maybe get to where I need. I can slow it down. But that's what's nice about recorded lectures. Okay, so as you get in things where any recordings, feel free to use those. And again, also you can jump ahead if I remember the beginning, or I missed the first part, or I had to leave early, so I'm going to jump ahead and watch the last part. Whatever you need to do, those resources are here. Okay. And remember, this is like a survey course. So if you miss one chapter, what might be better is just come back, pick up where we're at, and pick it up later. What we're doing today does not necessarily depend on what we did last week on chapter 1. Chapter 1 was about converting measurements of unit, primarily fractions. Today's lecture is going to be about linear equations. So it's a little bit more, it's kind of a little algebra unit built in here. So regardless of what you've done with chapter 1, whether you finish or not, we're on to something kind of a different topic, so you can just pick up this, work through it. And then chapter 3 will be on exponential, which is there's a connection, but it's a little different as well. Okay. Sometimes I have like PowerPoint presentations. What I'm going to do with this lesson, since it's primarily solving equations and linear equations that you may be familiar with, maybe you've seen them a few years ago. What I'm going to do is I'm going to show you how, so part of what we're looking at is different ways of learning. So I'm going to go into the textbook itself So I just opened up the textbook chapter 2. Um, and what I did is here they've got learning objectives. We need to solve one-step, two-step, and multi-step equations. So we're going to do that in the beginning, and I'll have a Word document open. I'm just going to give some examples. We'll work through those, what those are. We're supposed to recognize a linear equation and such. So we'll do some of that. We're supposed to solve some application problems and calculate slope and intercept as a rate of change. So we'll do all of this. For the application problems, that's where the quiz will come in. We'll actually just jump into the quiz because we'll have learned the skills to do that. And then we'll see how, if I got a word problem, right, how do I use the skills that we've got. Okay. And then what you can do is you can see through here, they've got those sections, and in the textbook, they've got some definitions. They've got some properties, so this is more formalized. They've got some examples, but what I do is I don't focus on vocabulary. I focus on doing things. It doesn't really matter what we call them as long as we know what we're doing. And we'll sort of start here with looking at examples of how things work. Okay, but if you come back again, some of you are going to have a learning style where it's very beneficial for you to see the printed word, right, to read. Some of us, I'm dyslexic, so when I read, it's just like all over the page. Sometimes that doesn't help me. I need to hear it, or I need to hear it and see it. So we're always working to fit in with multiple learning styles as we go forward. Okay, so let's see. What I like about Word, I use it as a whiteboard because it records things down, and it's got a little draw program in here. So first we're going to talk about solving equations. First of all, what is an equation? What is something that an equation needs? Equal sign, good. I was going to go, is this an equation? No, there's no equal sign. It's an expression, so we get these two different. So this is an expression that we work with it, but it's not an equation until, so oftentimes there'll be an expression on one side and an expression on the other. Okay, so that's now an equation. There has to be that equal sign. That equal sign is right in the middle of two expressions, right? There's a left side and a right side. And what does that equal sign mean? What's some other words we could use for the equal? It could be the sum of something. Yeah, for adding two, we would call the other side the sum of those two. So it's saying that equal sign, saying this is the sum of that. But what's the relationship of the left side to the right side when we have an equal sign? They're equal to each other. Good. So they're equal, they're equivalent. So what this is saying is that, in a sense, it's saying that both sides are 7, right? It's saying the left side is 7, the right side is 7. Or it's saying the left side is 3x plus 5 and the right side is 3x plus 5, that those are equivalent to each other. They're identical, really, in a way, at least in value. They don't look identical, they look different, but it's saying that somehow these things are the same thing. Okay. So if you have two things that are the same thing, so another way to envision this is that equal sign can be like a balance beam. And if it's equal, it's balanced, right? Whatever's on this side is the same weight or whatever, the same, it's equivalent to what's on the other side. So we've got balance. It's another way to think of it. If we have balance, and let's think of this, and we were to take a little piece from the left side, cut this piece out, what's going to happen? Will they still be balanced? No. But what if we cut the same amount out of the other side? Now they'll be balanced. So they will stay balanced as long as whatever we do to one side, we do the same thing to the other. So that's the idea behind what we're going to do today. We do the same thing to both sides, we keep the balance. Okay? And that's what we think of equality, right? You got two cousins, they're identical, two identical cousins. You give one an ice cream cone, what better you do to the other cousin? You better give them an ice cream cone too, because you're going to have problems, right? But if you do it to both, and make sure they're the same size, right? Because they're going to look, oh, they got more than me, right? I was that kid too. So, but whatever we do to one side, we do the same thing to the other side. We keep balance. We keep this piece, and that's the whole thing of what we're going to do. Okay. The other part is how many of you in growing up were a little bit rebellious? Your parents told you to do this thing, but you'd always do the opposite thing. I was one of those kids too. Try not to be too, in their face about it, but go to bed early. Nah, I'm going to stay up and party, whatever. So that you're going to be good at algebra, because what we're going to do is it's all about algebra is about what we're doing is finding out what this variable or this letter is. This letter is just a number that we don't know what it is. Okay, we want to figure out what it is, and so what we'll do is when they tell us to add, we're going to subtract. When they tell us to multiply, we're going to divide. When they tell us to divide, we're going to multiply. So we're always going to be doing the opposite. We'll also see we'll be doing this in opposite order of operations. And our whole goal is to do the math so that we get what the x by itself, and we get some sort of answer over here, some sort of number. So that's what we're doing with this solve. That's really all it is. So it takes its two properties. Equals means they're the same, so we can do whatever we want as long as we do it to both sides. That's the key part. And what we want to do is we want to get the side that has the variable on it, we want to do the opposite operations to all the numbers. So if we're multiplying, we'll divide. If we're adding, we'll subtract, and vice versa. Okay, but we have, whatever we do to one side, we got to do to the other side to maintain that balance, and we'll be able to solve equations. So we're going to start off with what they call just a one-step operation. And why? Because there's only one step to do. So we might have an equation. We'll come to this one. This is the one I've got up there is actually a two-step, so we won't start off with that. But I get to have, say, 2x equals 8. So what I'm reading this is that whatever the 2x, it's the same thing as 8. I'm taking 2 times something to get me 8. You may already have solved it in your mind, but we're going to just learn some techniques that when it's a little more complicated or that doesn't come to us right away, we can do that. So the first thing is we want to get the x, the variable, and x is just, one of my students put it perfectly back when I taught at Oregon State University. He says, so x just kind of marks the spot. And it's like a treasure map. It's marking the spot. Exactly. It's not really a letter. It's just marking a spot that, hey, there's a number here, but we don't know what it is. So that's what you want to think of the variables. That's how we're going to use them. So what are we doing to that variable? Operationally, addition, subtract, multiplying. So if we're going to get this by itself, how do we undo multiplication? We divide. So again, this is where we come in. We're rebellious folks. We do the opposite. We're not going to multiply, we're going to divide, but we do it to both sides. Okay, so whatever you do to one, we do to the other. 2 divided by 2 is 1. So that gives us a 1x, or just, 1 times x. Anything times 1 is itself. So that really leaves the x by itself. 8 divided by 2, 4. And we could go back and check. If I put the 4 in the place of the x, 2 times 4, does that equal 8? Well, yes, it does. So we can, that's the nice thing about this. Once we solve it, we can always go back to the original, plug it in, and check our answer. And then we know we're right. That's a one step. Let's see if I had this as an example. On this one, again, another one-step equation. What would I do here? Exactly. I see add 4. No, I'm going to subtract 4. I do the opposite. What I do to one side, you got to do to the other. And remember the sides, sometimes we get going and these equal signs get a little small. Sometimes what I will do is I'll put like a little dotted line to remind me of which side, because we're going to get where there's going to be bigger expressions, and sometimes I get a little sloppy and I forget which side is which. And so what you'd start doing is sometimes it's possible to maybe subtract 4 from both on the same side because it got a little messy. Um, I do that. Um, so we're going to subtract the 4. Again, that gives us 0, so we get x plus 0, which is just x, right? When you add 0, nothing happens, equals 7 minus 4 gives us 3. And you might have seen that. Well, if I put 3 plus 4, I get 7, right? So I could plug it back in. I put the 3 here for the x, add 4. Yeah, that gives me 7. I check. Okay, one-step equations. That's the basis of everything. If I had subtraction, I would have added, right? If I had division, let's do one of those because we're gonna have something like that. So what if I had x divided by 5 equals 10? What do we do here? We multiply by 5. So we look at it, it looks like a fraction, yes, but fraction just really means we're dividing. So we're dividing by 5, so we multiply by 5. So I just go 5 times from up here. What I do to one side, I got to do to the other side. Even though we're multiplying, this is where it gets, what do we do is well, the one 5 is in the bottom, the other 5 is in the top. So we'll actually, on this side, we'll divide to cancel out, right? 5 divided by 5 is 1. So that just gives us our x. On this side, 10 times 5 is 50. You could. You could. In fact, we will, let me show you that. Good question. Because that's actually what we're going to do in chapter 3, because we're going to set up proportions. In this set, we're thinking this way. But yes, you could have thought of this as, so another way to work this specific one, if you look at it as a proportion, is to cross multiply. 1 times x, 5 times 7. So there's 1 times x equals 50. It would have worked, right? We got the same answer. And that's the nice thing about algebra. There's more than one way to do things and think about things. And sometimes teachers, no, that's not part of the lesson today. Well, but it works. That'll be part of the lesson next week. And so you're going to see that connection. And you may favor one over the other. You go, oh, wow, yeah, cross multiplication. I love it. So we'll go with that. So it will work that way. Yeah, good call. Good call. And again, plug it back in. It works. So far, are we good with one steps? Okay, let's going to give myself another page. Gives me the page up here. Yeah. So we'll go with what we call two-step equations. And so for these, let's take that first one. We have what, 3x plus 5 equals 7. We can solve this one. So you can see there's 2 steps now. What is this? If I were to say order of operations, does that ring bells with anybody? What if I said, please excuse my dear Aunt Sally? I don't know where that comes from, but yes, I do. Parentheses, exponents, please excuse multiplication. My dear, division, Aunt Sally. So if you've learned this, the PEMDAS maybe is how you learned it, whatever. But order of operations, we do parentheses first, exponents, multiplication, division, addition, subtraction. But since we're rebellious, we go, everything's backwards. So what are we going to do? We're going to do something called SAD MEP, which is PEMDAS backwards. In the two steps, yes. So we are going to do things backwards. We're going to take care of the addition subtraction part of the equation before we take care of the multiplication. Because think about this. When any of you work on a car or do some mechanical work or take things apart, how many of you were a kid that liked to take things apart? Fix a tire. Yeah, I always take things apart. I rarely got them back together the same way, but I like taking things apart. But what you find is when you take something apart, you have to do everything the opposite of when you put it back together, right? The stuff in the middle has to happen first. You can't put it in at the end. You gotta build from the inside out. But if you're taking apart, you go from the outside in. So that's what we're doing is we're working when we're solving something, we're working from within. So what we will do, there's two things that are happening here. There's a multiplication, 3 times x, so we want to do the opposite, and then there's a plus 5. But it's important we do it in the opposite order because usually we would take care of multiplication first, right? That's what we've been taught for years. But in solving, we want to do it in the opposite order. So instead of adding, what are we going to do? We're going to subtract. So we're doing opposite things in the opposite order, and whatever we do to one side, we do to the other. Okay, so that's the whole key. And again, that equal sign is a very important thing. It looks like a little symbol, but it's dividing this expression. There's one expression, there's a left side and a right side. So I've done it to both sides, so I'm going to keep it equal. Plus 5 minus 5, that's 0. So I get 3x plus 0. Don't have to write the 0. And I get 7 minus 5, so I get a 2. But I don't have the x by itself yet, do I? Now what do I do to get that x so it doesn't have someone else there? I divide, always the opposite. So just like I think of it as a party, x is having a party. How do you get people to come to your party? You invite them. How do you get them out of your party? You uninvite them. Go home, I'm tired, I want to sleep. So this is the old man saying, time to get going. Divide them out. I always like to make stories up. Makes it more interesting. So numbers have personality. So we divide by 3. 3 divided by 3, look at it, got rid of them. We disinvited the 3. So we now got x equals 2/3. You could turn it into a decimal. It would be 0.6666, but a lot of times we're going to leave them just as decimals. Again, we could plug it back in. 3 times 2/3 plus 5. Does that equal 7? Well, the 3 divided by 3 cancels, so then you get 2 plus 5. Does that equal 7? Yes, it does. I can see 2 plus 5 is 7. So it kind of gives a check, right? We can always check our answers. But sometimes a check is more work, and so as long as I'm careful and did it, I usually don't like working with fractions either. So I just, okay, I think I did everything right. There we go. Put in your answer, check it, it'll do it. But that's a 2-step, right? So the 2 steps, we're doing the opposite things, but we're also doing them in the opposite order. Okay. So far, so good? Let's go for one, maybe a little more challenging one. Let's go for 2/3 x equals 14. I look at that, and I'm calling this a 2-step. I could do this also as a 1-step, but if I look at this as a 2-step, what are the 2 things that are happening to that variable? Yes, but so it's like 2x, 2/3 x, or so 2/3 times x. So I can look at it as a 1-step, a 2/3 times x. So we'll do this kind of both ways. But what is the 2, when I've got a fraction, what does the 2 do to the x? Good. We could put the x over 1, look at it as a fraction. So we're going to multiply by 2, and then what are we doing with the 3? We're dividing. So that's why I can look at this as a two-step, right? So maybe I want to undo the 3, so I can multiply both sides by 3 first. 3 divided by 3 is 1. So then I've got 2x. 14 times 3, that's a big number. That's 12. 3, carry the 1, 40, 42. Sometimes, watch me, because sometimes I get these wrong. So you say, oh, he's a math teacher. He must know what he's doing. Not always, especially with arithmetic. I just kind of, okay. Now what do we need to do? Because we don't have x by itself yet. We then divide by 2. And we get x equals 21. And again, we could plug in the 21 divided by 3 is 7. 7 times 2 is 14. So it works. So you can also do your check just sort of mentally going back and forth if you want. You don't always have to do the check, but it's helpful, right? Especially like I told you, our tests are going to be multiple choice, so you'll have the answers. So if you can't get there forward, well, just take the answers and check them, right? That's a good strategy. However, while we could do this as a two-step, when we've got a fraction, I'm going to show you an alternate method here. We could also do this as a one-step. And this is sometimes a little challenging, so that's why I show them both. The two-step, viewing it as a two-step might be a good process for you. If we've got a fraction, how can we sort of get rid of that fraction in one step? Or how can we get that fraction to become 1, the number 1? Watch this. I'll just do this in general. If I have a over b, just using letters, and I multiply by b over a, whatever they are, what's going to happen? What is a divided by a? 1. What is b divided by b? 1. Anything divided by itself is 1. We talked about that last lesson. This gives us 1. What do we call the relationship between b over a and a over b? It's a reciprocal. Oh, I don't know if I can spell that. Reciprocal. Maybe that's the right way spelling. So reciprocal. So if you flip a fraction, that's what I like to call it. It's just a fraction flipped, and multiply it, you're going to turn it into 1. So this is a key way to sort of get rid of a fraction. So we could look this, instead of saying I'm going to have to multiply by 3 and then divide by 2, I can do it in one fell swoop. I'm going to multiply by 3 and divide by 2. So I'm going to multiply by the reciprocal, and in one step, I'm going to take care of this, right? 3 divided by 3 is 1, 2 divided by 2. I got this taken care of in one step. But if I did this on one side, 3 halves, I've got to do it on this side. And again, I like to, if we're going to multiply by a fraction, turn it in there. So, but again, sometimes check yourself. Which one feels more comfortable to you? Work with the comfortable one, and then maybe try to figure out the other one. And again, we sort of do things backwards. Usually you do 14 times 3, right? You're taught to multiply fractions straight across, but you can also reduce it. So 14 divided by, we can do the division first, and so then we're not going to have to reduce it later. 14 divided by 2 is 7. 7 times 3 is 21. Notice we came up with the same answer, but we did it in one step. Okay, so we'll try to work with you a little bit to do that one-step thing when you got a fraction. And again, I've taught for 26 years. This is usually when we get to fractions, that's the part that if you understand everything else, fractions just make things more complicated. But just remember, a fraction has two parts. There's a multiplication on the top, there's a division on the bottom, And we can handle it in one step if we want, or two steps. But look at that fraction as kind of two things going on. And then you're just fine. Okay, that's a two-step. Any questions? Doing okay? Feel comfortable? We'll go to the next level of difficulty, and then we'll be done solving equations. Well, actually, this is a whole lesson on solving equations, but then we're going to use it for understanding linear equations of specific type. Actually, what we've been working with are linear equations, but we're going to do it with two variables, x and y, not just x. Okay, so this last one, let's go with something like this. 3x plus 5 equals 4x minus 7. Okay, so again, we want to focus on that equal sign. That equal sign divides our equation into two sides. How is this one a little different than the ones we've been working with so far? We've got some like terms here, but we got them on opposite sides of the equal sign, right? I think of this as a river and we're having a picnic. So let's get the family together, get the x's together. So I want to bring either the 3x over to the 4x or the 4x over to the 3x. How can I make that happen? How would I do that? Good. Very good. So if I subtract the 3x, it will disappear from this side. It becomes 0, right? 3x minus 3x is going to be 0. But what I do to one side, I have to do the same to the other. Even though I don't know what x is yet, I just treat it as if whatever it is, well, that's what it's going to be. So very good. And that's sometimes the hardest one because people, what do? I got these two x's. So let me do with the other stuff. And then it's just, but if just bring the family together is what I say. And it's going to be so much easier because now it's going to look like the stuff we've been doing, right? So this becomes 0. This becomes 5. On this side, 4x minus 3x is now 1x. That's good. Minus 7. Now this one used to give me a lot of troubles because the x in my mind is on the wrong side of the equal sign, right? Usually at least that's how we read from left to right. If you're more comfortable having the x on the left-hand side, well, we could rewrite this as x minus 7 equals 5. We could flip that because if left equals right, then right equals left. We can move it however we want to make it comfortable for ourselves. I did this for years. Eventually, I became comfortable having it on the other side. If you're comfortable with this in this form, add 7 to both sides, and we'll get what? We'll get 12 equals x. That's okay. If it's more comfortable this way, add the 7 to both sides. X equals 12. And the way I help myself is I would do it this way because this is much more comfortable for me. And again, for me, order is very important because the way I see things, the way my mind was seeing things. But I would do that and I say, okay, I could have done it this way. I could have done 5 equals x minus 7. I could add 7 to both sides. And I get 12 equals x, which is x equals, okay. And I would work myself, but that would help stretch my abilities. But if I found when I went directly to this way, the way my mind worked, that was a lot harder step to take. And I wouldn't feel as confident. I feel much more confident over here. One thing is I got a teacher who said, yeah, you could do that. Just flip them over. So they encouraged me to do it this way. It was easier for me to do. I get the answer right, and then I stretch myself this way. So when you can work both ways, it's a little nicer. But again, equal sign, we can do it however we want to do it. If you're not sure, just flip it over and we can get our answer. So that's the multi-step when we have x's on the other side. But again, it's just add or subtract them. If it was a -3, we would have added 3x, right? We're just trying to turn it into 0. And that's all algebra is turning things either in. Notice we would either turn things into zeros if we were adding or subtracting, or if we were multiplying or dividing, we were turning things into 1. Because when you multiply by 1, nothing happens. When you add 0, nothing happens. That's all the algebra is. Okay? And whatever we do to one side, we do to the other. Again, if you've got two cousins, just think about that. You ever buy ice cream for one, you better do it for the other. Um, again, assuming they both like ice cream, but you got to be equal to your um, to the kids. Okay, so now we're good on time, right? It's 10:30. Yeah. Um, we're going to get into this part on linear equations. We're going to see it's kind of related to what we're doing, but it's also a little different. So we saw that when we talked about equations, we sort of focused on this word equal. That was sort of the first part of equations. We need an equal sign. If we're talking about linear equations, what is the key phrase we're focusing on? This word line. We're dealing with stuff that when we graph it, becomes a line. And there's one type of equation in particular that gives us a line, and we're going to do that. So what is a line in mathematics? Let's just look at a graph. Is this a line? It's a curve. In mathematics, we call it a curve. Now, in our vernacular, we say, oh yeah, draw a line. We'd have curve. We'd call that maybe a curved line. But in mathematics, there are no such things as curved lines. There are curves and there are lines. A line has to be, back this up. There we go. Not that far. A line has to be a straight line. It has to be straight. So a line in math is just a straight line. But again, we use this word in everyday life. If we see, follow the line, right? Follow the yellow brick road. It can curve, but in math, it has to be straight. So what are the qualities of a line? Do lines have starts or ending? They're infinite. They go in both directions forever. That's at least the mathematical concept when we talk about the line. That's where they don't ever stop. We talk about line segments, which do stop and end, but that's a special type, right? When we're just talking linear equations, they go infinitely in each direction. How thick is a line? Good. It has no thickness. Now we draw it, to be able to see it, it has to have a thickness, right? So we talk about thick lines and thin lines, but mathematically all lines have really the same width, which is nothing. They're a collection of points. How many points are on a line? At least two. Good. Yes. And the thing is, the definition of a line is that they are a collection of an infinite number of points. So there are more than the two, but what we're going to focus on is we need the two. If we have two, we can determine this particular line. Because if you have 2 points, how many lines can you draw through them? So this one, I got these 2 points. Can I draw more than one line through those 2 points? How? If I go through this point, oops, if I keep it straight, I can't get to that other point. I'd have to do a curve, but a curve is not a line. So that's the key part. This doesn't count. I can't do a curved line. So when I'm thinking straight lines, there is only one straight line that goes between 2 points. That's why they'll say the shortest distance between 2 points is a straight line. And there's only one way to get there. Again, in the real world, somebody's got property, we got to go around things. We got to do curved lines to get from A to B. But if we could do the straight line, that's going to be the shortest. So if we've got 2 points, there's only going to be one line that will do it. Okay. If we've got a line, we could choose any 2 points. Those will be the only 2 points on there. Okay. So yeah, we'll take this guy out. That's not possible. Any other line is not possible. There's only going to be one line. So there's a key part. Got 2 points, and we'll label them. We'll do coordinates. So we'll call one with an x variable. We'll use the other as a y variable. And so each point will have coordinates x, comma, y. So there'll be some numbers there that we'll put with them. Since we're going to have 2 points, we'll call one x1, y1, and the other x2, y2. Those little subscripts we could have used any number, but just to differentiate that we got 2 points. So again, we actually have more than them, but you'll see all the problems will typically involve 2 points. Because if we've got 2 points, we've got a unique line. Okay, almost there. What are the qualities of a line? Yes, sir. They would be these points. So I could call one of these points x2, y2, the other one x1, y1. So let's look at a specific example. 1, 2, 3, 1, 2, 3, 4. I'll put a point here, and this is the point. X always comes first, followed by y. And then we'll do a point down here. 1, 2, 3, 4, 5. 1, 2, 3. Put a point here. This is going to be -5, -3. What I'm going to do is I'm actually going to show you the way I do this is from 3,000-year-old techniques from ancient India. And they didn't use x1, y1, all these little subscript and algebra. They just did it visually. Okay, so we're going to kind of go from there. We'll come back and we'll bring in that formula because some of you may be familiar with it. Maybe that's where you're comfortable, but I'm going to show you the algebra of just location. So this line, the line that connects these 2 points, let's see if I can draw that. And again, usually my lines end up being a little curvy, but we'll pretend that's a straight line. So what are there's 2 qualities that a line has. Since it can't curve, right, it's got to be straight. Every line is straight. Every line is the same length. Every line is the same width. But what's the difference between this line and this line? Has to do, okay, so there's vertical lines, horizontal lines, diagonal lines. But what do we call this quality if we were to think of this as a hill, right? There's a steep hill and there's a less steep hill. What do we call that quality? Steep slope, the slope of it. So like I got cousins that are roofers. Actually, they're in North Dakota, so they don't get much work in the wintertime because you don't want to work on a roof when it's freezing out. But they did church steeples once, and those are very steep. So slope, yes. The steepness, we call that slope. What the slope is, it's a ratio of how far up you have to go for every time you go over, right? So the bigger the number means you go further up for going over. So the bigger the number, the steeper the line. The way we go about measuring that typically is we think of slope as the rise over the run. So rise is the change in the y values, how far up and down we go versus how far left and right we go. And so the rise comes from, let's change to blue here, how far up we go, we get from one point to the next one, and how far over we go. You're going to see is the rise part is determined by the y's. So we're going from -3 up to +4. We could kind of just count 1, 2, 3, 4, 5, 6, 7. So it's a rise of 7. We could also do that, the distance between 2 points, we can get that by subtraction. So I could take 4 minus -3. So I'm subtracting the y values, right? That will give me my rise. Gives me how far up I went. To get how far over, again, I could count 1, 2, 3, 4, 5, 6, 7, 8. Also, the distance between two values, I could do one subtraction. So I'll do this one as 3 minus negative 5, which is going to give us 3 plus 5 gives us that 8. Okay, so subtraction gives us how much distance we've covered. And then this ratio will give us our slope. So we would say this line has a slope of 7 over 8. So it's always how the vertical change over the horizontal change. Okay. So we call slope, there's equation, and this is what, again, maybe if you've had a algebra class that you remember, you might remember this formula, y2 minus y1. Say that, well, we're subtracting them, but when we subtract the negatives, it becomes addition, right? And then x2 minus x1. Okay. Does that look familiar to anybody? Okay, so, and we call slope, we're going to use the letter M for slope, and the reason that is because a lot of mathematics that we used today, it was first introduced in European textbooks. So in German, I guess, the word for slope starts with an M. I don't know what it is because I don't speak German, but that's where it comes from. That's what I've been told. But what I'm going to show you is we can get the slope, because you're going to be given two sets of points and asked to get the slope. The ancient way of doing that is to take the 2 points and you can put one over the other. So this is 3, 4, negative 5, negative 3. And we're going to see it doesn't matter which one I put on top or which one I put on the bottom. This comes, again, from ancient India. This is going to be a visual thing. It's going to be called vertically and crosswise. They had this saying in Sanskrit, but they did a lot of their math vertically and crosswise. Well, what do? If you remember this one, all you have to do is vertically, we are going to subtract. So remember, the first coordinate is the x, the second is the y. So we're going to take 3 minus negative 5. 3 minus negative 5 is actually 3 plus 5, right? That's going to give us 8. For the y, we do the same thing. So we got them lined up just straight down. We're going to take 4, subtract negative 3. Again, we can do this in India. They did most of their mathematics in their head because that's the way they did it. 4, subtract negative 3, so that's 4 plus 3, that's 7. The crosswise thing they did is they said, okay, this is the x, we have to put it underneath the y, so that's sort of a cross thing. Here's our slope, 7/8. Notice it's the same thing we got up here visually by drawing the graph, and we could count how far up we went and how far over. We can do it this way, and if we use this formula, we could have said, okay, what is y2? Y2 is this 4. What is y1? Negative 3. What is x1? Well, it's the first point, so I put the 3, subtract negative 5. So I can do it this way, but even though I'm a math teacher, I sometimes will still make mistakes with this because I get the numbers in the wrong place, right? The thing I like about the vertically and crosswise, I can just list the numbers above each other, and that's how we write them in ordered pair. Straight down, tuck it underneath, we're done. I don't mess up where the numbers go. This one, I will make some mistakes when I go through. 4 minus negative 3, well, that's 4 plus 3. that's our 7. 3 minus -5, that's 3 plus 5, there's our 8. We have a slope of 7/8. Okay, multiple ways to get it. Again, you kind of know where you feel maybe comfortable or whether you're not comfortable with something. Maybe it's always been taught to you as a formula and you've always struggled with it. That's where I was at um, until I found this new technique of vertically and crosswise, and I can get it right just about every time because I think more visually. It's more of a visual aspect, no formulas. So we can do that. Okay, so that gives us that one quality of how steep it is. It rises 7 and then it runs 8. So we get this kind of a steepness, right? If we come back to the line, so we've got steepness, we got slope. There is one other quality. I could have multiple lines that have a slope of 7/8. I could have this line right here that also has a slope of 7/8. But how is the blue line different than the red line? Slightly above, so height, right? And the way we're going to measure height, we could do it in multiple ways, but what we'll do is we'll measure where does it cross the right y-axis. Okay, so a line has just two qualities. It has its steepness and it has its height, whether it's high or low. And so what that gives us is when we come to talk about the equation of a line, we've got two variables, right? We've got a y variable, we've got an x variable, we've got its slope. And we're going to see that the equation will work out if we take the slope times x, the height is added to this, and I'll call that height. And so we get this equation of y equals, we use m for slope, and for the height, I don't know if it's I before E or we use the letter B. This is the equation of a line. So this is an equation so it's a linear equation. Specifically, you might, again, more vocabulary, they call it the slope-intercept form because they have the slope and the y-intercept. So it's also called the slope-intercept form of a line. There's more ways we could write this because we can do algebra, we can move things around. But so far, our line that we have there would be y equals 7/8 x. And then now all we got to figure out is what is that y-intercept, right? So what is this number here? Looking at it, we might be able to say it. I think when I've got this is 4. It might be 1. I'm not quite sure, but there's a way we can find out, and that's going to involve solving equations. Okay, so I found my slope. To find my y-intercept, which we'll do a little bit of this, what I need to do is plug in some value, so I only have one variable, one unknown. So I can take one of the points that I was given, either 3, 4, or -5, -3. Which one would you like to use? 3, 4. We'll get the same answer, so I'm with you. I would rather use 2 positive numbers than 2 negative numbers because that's when I'm going to make mistakes. So what I do is I'm going to take this point 3, 4. It means I can plug in 3 for x, so I get 7/8 times 3 will be equal to the y value of 4. And notice now I've got an equation where there's only one unknown, the value of b. Now this is not going to, I, I didn't choose very wisely. I just chose randomly, so we don't get very pretty numbers, do we? Um, 7 times 3 is 21 over 8. I did that. Let me just multiply that. How do I get b by itself? Well, what am I doing with 21/8? I would need to subtract 21/8 from both sides, right? Minus 21/8 minus 21/8. This is 0. I'll get b equals 4. Right, because this is really like 3 over 1. So I multiply the 7 by 3, but the 8 by 1. Good, good call. So that's, yeah. So 4 minus 21/8. Again, not a very pretty number. We're not going to have to do these type of things. So and the homework problems we're going to see, the ones that they give us will give us nicer numbers. But let's just talk about this. I don't think we've done that. But how do we add? So we've got a fraction here, 21/8. Two things we could do, right? We could get a common denominator. What could we do with 21/8? We turn that to a decimal. Take 21 divided by 8 on a calculator, and it'll be a relatively nice fraction. I did. So that's once you practice a little bit, you can see you can remember if 4 equals b, you could bring the b over and bring the other stuff to the other side. But if it's, again, if that's a little confusing, we could have just as easily said it's 4 minus 8/21 equals b here, right? Because equal sign, we could do it either way. So I'm going to turn 21/8 into a decimal, so I can do this all with my calculator. 21/8 is 2.625. And now I can use a calculator. 4 minus 2.625 is 1.375. So now I've got my linear equation. Put it over here. Let's do it in red. Y equals 7/8 slope times x plus 1.375. So it was close to 1, but it's a little bit higher. If I actually graph this, that's my equation of the line. Yes. So to get that number, I took 21 divided by 8. And again, think of fractions as just a division problem. And if you do that, then the calculator can handle most of the calculation part, and we're all good. So after doing all of this, what we see is that lines have two qualities. They've got a steepness, which we call slope, and then they have a height, which we measure from the y-intercept. Okay, this is called the y-intercept, which means that's where it crosses the y-axis. We also call this the initial value, the starting value, because it's where x equals 0, right? The y-axis, x is not gone to the left or right, so we also call this an initial value. 7/8 we call the slope. We also call it the rate of change. Because a rate of change is like miles per hour, right? This is how many y's per x. So we have a rise over run. So it's also called a rate of change. Okay, so we're going to use those interchangeably. A slope is the rate of change. So if you're on a roof, you have to go up or down. So now let's one more step, and then what we're going to do is we're going to look at the quiz, and you're going to see we've covered everything we need to be able to do the types of questions we're going to have in the homework and the quiz. Let me give myself one more blank page. Come back up here. Go in the middle here. So we've got okay. So if we're looking at this one, how would this one, so if I give you a line, a linear equation, how do I go about graphing it? We could, but actually you'll see there's no way to solve for x, because whatever x is, y will be different. So there's multiple points. We could try to figure out what 2 points are. But what do we have here in this equation? We've got an equal sign. What does this number give us here in front of the x? Our slope, our rate of change. So if we had a starting point, we could use that rate of change to get to the next point. Do we have a starting point? 1. And that's the y-intercept, the initial value. It's really the point when x is 0, y is 1. And notice if you put in 0 for x, this part goes away, y is going to be equal to 1. So that we always have a starting point. So what we graph is 0, 1. We've got a starting point. This slope we could think of as either -2 over 3, or we could think of it as +2 over -3. Yes. Yes. And if there's no b there, it's that your starting point is 0, 0, 0. So sometimes it's invisible, right? So if I didn't have a 1 here, I would have to recognize that that would start at 0, 0. The slope gets us to another point, okay? Let's use this one, -2 over 3. So we rise -2. You rise -2, which direction are you going? Down. So we come down 2, and then we run 3 in the positive direction. 1, 2, 3, and we have another point here. If we use the other one, 2 over -3, we go up 2, but we go backwards 3. 1, 2, 3, and we get this point. You can see they're both on the same line. Okay, so that's just a way of thinking. But if I have a negative slope, how would I describe this line? This line increasing, decreasing? It's decreasing. It's a decreasing line. So whenever we have a negative slope, we're going to get a line that's decreasing. I went back to that other line, which I don't know where it went now, but let's see if we can find it. This, as we found out, where's my equation? There it is. It's got a positive slope. And how would you describe that line? Increasing, right? It's going up from left to right. Okay, so those are 2 things, and you're going to see in the homework we've got this where they'll give you a linear equation. They'll ask you, is the line increasing, decreasing? 2 other things that can happen is we could have a horizontal line y equals 0x plus 5. So again, the starting point is 0, 5. 0, 1, 2, 3, 4, 5. This is 0x, so that means we rise 0, maybe run 1, rise 0, run 1, rise 0, run 1. That's going to give us a horizontal line. Okay. Now you usually won't see 0x, because 0 times x is 0. You'll usually just see this as y equals 5. So when the x is invisible, what you know is you've got y equals is going to give you a horizontal line. Okay? So we have increasing, we've got decreasing, we've got horizontal. What's the last type of line we could have? A vertical line. And where's that going to come from? Well, if y equals 5 gives us horizontal, does it make sense that x equals 5 would give us a vertical line at 5, at x equals 5? So that's going to be over here at 5. It will be a vertical line. The slope here, though, we call this undefined slope, because this is really, it's all rise and no run, right? So it's rising 1, but it's running 0. And mathematically, when we divide by 0, I think we had some of these, what happens? Undefined. It's actually infinity. So a vertical line has infinite slope. It's as steep as you can get. You can't get steeper than this, because if you get more steep, then you're actually coming down, but it's less. The vertical line is as steep as you can get. So this has undefined slope. The other thing is a vertical line. Does a vertical line have a y-intercept? Will it ever be able to cross the y-axis? No, it's like train tracks. Do they ever? Well, maybe they do meet, but you shouldn't cross the train tracks, right? They're parallel. So no, there is no y-intercept. So this vertical lines typically, they break the mold. They don't have a y-intercept. It's not that they don't have slope, it's undefined slope. But this is typically the hardest one because it's outside the other ones. So those are all our linear equations. We're going to need to find slope. We're going to need, when we have a slope, determine whether it's increasing, decreasing, horizontal, or undefined. And I think that's pretty much it of what we're going to need to do for our lesson. And then now we're going to do the quiz. We're going to see these are, again, the quiz is kind of indicating the types that will be on the exam as well. But it's kind of, these are the important ones. When you go back to the homework, it'll just give you more practice, but we should be pretty good at it. And remember, next Monday is a tutored math day. So come here. If you get the homework done early, this is a little indication, like over the weekend, you get it all done. Someone said, do I have to come? I said, only if you've got questions, only if you want to work on things. If you want to get ahead, you're always welcome to come, but you are the one that gets to decide whether you need to be here or not. And again, I record things when you can't be here and all that kind of stuff. So let's go ahead and take a look at this. Oops, I need to restart it because I did it with the other class. So let's see, submit and end. Let's retake it. And you can take these multiple times as you need to. Remember, we're looking to get you to 70%. That's going to say you've got enough proficiency to get on. So let me make it a little bit bigger and move it up. And see, I've got my thing here. So this one, solve the following equation. Write your answer as an integer, proper fraction, or mixed number. Okay, so we want to solve this equation. Is this a one-step, two-step, multi-step? Good, it's a two-step. Yeah, there's a division by 4, there's a minus 3. Now, typically we would say, the way this is set up, should I deal with the subtraction first? What is the kind of, what would be my first step that you see here? We do, except this is sort of, so what we want to see is that this is a really, when we've got fractions, that's sort of a parentheses around there. So parentheses we do last. So what's, because we can't really just subtract 3 or add 3, right? Because we got this 4 down here. How do we undo division? We really got to multiply by 4, the opposite, right? Multiply by 4 first. Okay, so 4 divided by 4 is going to give us 1. So then we have d minus 3. 8 times 4 is 32. Okay, so that's our first step. So when you see a fraction, don't just remember that's indicating division. Sometimes we have to play with these. And then what do we do next? Plus 3. Do the opposite. Do it to both sides. D equals 35. We can put that in here. I can click here and it'll give me my answer is 35. Again, you'd also put the 35 back in for D, subtract 3, divide by 4, you should get 8. But your answers have, oh, I've got to actually enter it in here. Doesn't recognize my writing. And there we are. Okay, so there's one. And again, the one you have in your quiz may be a little different, but that's, you'll see some homework problems where they give you an equation, just ask you to solve it. You go through, you get multiple tries through here. This is an application type problem. What I'm also going to do here is coach you on a way that I've come about solving word problems. I do not read word problems. Well, I do eventually, but I don't start there. What I do is I do this backwards. I look for where's the question. So what I found is when you come here, if you will read the first sentence, so like a book, go to the last page, see if it's a book that you know, is it a happy ending or a sad ending? What do you want? So I go to the end because this is going to tell me what they're looking for. It gives me the question. We're asked to determine the age of a person whose target heart rate is 156 beats per minute. So we're looking, determine the age. The question is, we're trying to find someone's age. We're told that they're going to have a target heart rate, and we're given a number. Okay, I have no idea what this means yet, but I know what the question is. I'm looking for somebody's age. I work backwards. Now what I look for, I don't read. I look for equations and numbers and letters so that they might define it. So I said, right away, I see an equation here. Ooh, that's kind of cool. They've got the M and they've got an A. Maybe A means age. See, this equation gives the recommended maximum heart rate. Okay, so M stands for maximum heart rate. That was something about a target heart rate. The formula here, I see about 80 beats per minute for a person who is age A. So A is the age. That's what we're looking for, right? So see, I haven't even read the question completely, but I know what I'm looking for. I got an equation that has M and A. I know we're looking for A. And so what must this 156 is beats per minute. That's my M. So I don't actually even have to go back. And if you did, you'll see that the first 2 sentences are just kind of fluff. But the problem is if you start from the beginning, your mind will start thinking. Did I tell you one about the school bus? No. Okay, that's my story. Your brother or sister. My sister did this to me, and unfortunately, she did it several times. So here's this thing: okay, kids are getting picked up by a blue school bus. The first stop, 5 students get on. Next stop, 10 students get on. The third stop, 2 students get off. And then the next stop, 15 students get on. Now, what were you maybe doing when maybe you were thinking, this is what start adding up the students because you think the question is going to be how many students are on the bus, right? But no, the question is, what color was the bus? Well, I forgot what color the bus was because I was adding and subtracting students. It's the trick is look at what the question is before you start reading the question. What are they asking before I start reading all this stuff that because my mind's going to start thinking and trying to solve problems that they're not even asking. Okay, read the question backwards. Go to the question mark or go to that last sentence. It'll tell you what they want. It'll make it a lot easier. I don't really have to read all this stuff. You could if you want, but I now know I've got this equation, and I'll do it up here. M equals 0.8 to 20 minus A. I know I'm solving for A because I need the age. And so they give me that this is beats per minute, 156. So I know that M is a number of 156. Now I just need to solve for A. That's all I got to do. Didn't have to read the whole thing. Okay. Again, you could go back so do that. Look for a lot of these are going to have an equation in there. They're going to give you what are you solving for. So how do I go about solving this? I need to get A, parentheses I do actually last, right? Because I'm doing the SADMAP. That's the last thing I do. So what do I want to do first? Okay, so there's this parentheses here. I always put, so what are we doing outside of that's implied multiplication? We're going to do the thing, we're going to do the opposite thing. We're going to divide. Now you could distribute. If you were thinking you could distribute first, but actually you're going to see you'll save yourself if you just say, well, let's divide before we do the parentheses thing. Divide by 0.8. And most of these we can use on our calculator. 156 divided by 0.8 gives us 195. Move that up here. So we got 195 equals 220 minus A. Get out of the way. All right, parentheses. So we're okay with that? Sort of solving. This is an application problem. What do we do next? Add what? Good idea, the 220, but since it's positive, how do we get it to be 0? We subtract it. So it's, yeah, you're seeing the subtraction here, but that applies to the A. So the 220 is positive. To get rid of it, we're actually going to subtract it. Oops. We will. And we're going to think of that negative as -1. So we're going to divide by -1 on that step. So that's excellent. So we subtract 220. Because otherwise we do this and we see, oh, we get a negative number. And remember, A is age. So how could somebody be a negative age, right? This is 15? No, 20, 25. -25 equals -A. And we could think of this as -1A. So how do we get rid of -1A? -1 times A. Divide by -1. So that gives us that A, the age, is 25 years. Negative divided by negative is positive. Turns to positive. Again, just solving, but these will help you as you go through any type of word problem. Just get in that habit of reading the last sentence first so you know what they're asking, and that typically will help you go through it. That's sort of one of the advantages I have being dyslexic. I typically read backwards, and I just thought, I'm pretty good at solving word problems because I'm doing it wrong. Everyone says read it and then read it again and do it. No, don't follow that advice. Anyway, let's check our answer. Got it right. Yeah, if we got it wrong, we could have another try. And we could always work these again if need be. I've got multiple things in there, but we got it right. So we move on. Okay, so you have some application problems, you got some solving problems. Here we got a question asking us to find the slope. They give us 2 points. How do we find the slope? this. Remember, just think here vertically and crosswise. So we take one point and put it above the other. It doesn't really matter which. Maybe I'll put the 9 minus 6 above here. And I'm going to vertically subtract. So 9 subtract negative 10. By subtracting a negative, it becomes plus. So 9 plus 10 is 19. I've got negative 6 minus 6. Negative 6 minus 6 is negative 12. Good. Some people will think that that's 0, but that's not right. Minus 6 minus, yes. So we, okay, good. Right, so you would be subtracting. Exactly. So again, and that's the way it'll all work, is we can set them up different ways, but you'll have slightly different numbers. So yes, we're always subtracting, but if we're subtracting a negative, then it becomes addition, right? And then the last step, we take the x, we do the crosswise, put it underneath the y. So for me, my slope is negative 12/19. Notice I could have used that formula y1, y2 minus y1 over x2 minus x1, but that, again, causes trouble. Vertically and crosswise. So vertically we subtract, crosswise we come over here, we enter our answer. They got a little fraction thing here. Check our answer, and we got it right. I have this little key. We could also put it in as a decimal, I guess. They give us a decimal here. Questions on that one? Got 2 points, vertically and crosswise. Did it work out? Okay. We'll take a look at some of these. So again, sometimes it's just the follow through and the calculation itself may get there. Okay. Vertically and crosswise, use that. Or if you want, oops. We have 9 minus 6. We got negative 10, 6. The other way is use that formula. This is what you're comfortable with. Choose one of the y's to be the y1. I'll do 6 minus negative 6. So if I use the 6 as the first one, then I would use the negative 10 here, minus 9. 6 plus 6 is 12. Negative 10 minus 9 is negative 19. Notice I got the same value, just the negatives in the other place. So it doesn't matter the order you do it in. Doesn't matter if you want to use the vertically crosswise or the formula method. You'll get the answer the same both ways. Yes. So 12 over negative 19 is the same thing as negative 12 over 19, which is the same thing as putting the negative in front and then just having 12 and 19. These fractions are all the same. And and the answer system will take all of those as correct. Good, good. So far, so good? Okay. And then we're going to get into question 4, and then we got 5, and then we got 6. So a couple different ones. But so for this one, we want the rate of change. Now remember, the rate of change is our slope, which is the number in front of the variable, in front of the x or the variable. So as we go through each of these equations, it's the number in front of the variable. We'll talk about this one in a moment. So in our equation here, this first one, what is our rate of change? 7. Not 7x, just 7. So the number in front is our slope. The equation does have a 7x, so it gets in there, but we'll see. Yeah, it's just a 7. What's our initial value? -2. It's the number that's by itself. Good. And then its behavior, is it horizontal, increasing, decreasing, or vertical? That comes from the rate of change. Since this rate of change is positive, it means it's going up, right? So it's increasing. Cool. How about the second one? What is our rate of change? It's -9. It's not the first 9. Now, that's one of the things you get is y equals mx plus b. So you think the first one's the slope. It's the one that's in front. So sometimes they switch it like this. You're right. This is -9 is our slope. Our initial value, though, the number by itself, is +9. Right? Teacher's version, I have all these. So since the slope is negative, what is the behavior of the line? Decreasing. It's going downhill. So think of that negative makes it go downhill. Good. Y equals 4a. What's our rate of change there? 4, the number in front of the variable. What's our initial value? 0. Because it's invisible, it's 4a plus 0, which they don't write. So good. Sometimes we'll see. So if we had just a, nothing in front of the a, then that means the slope was 1. So sometimes that, there we go. And what is the behavior of this line? What's the slope? The slope is positive. Yeah. So the initial value is 0. Yeah, if the slope was 0, then we're going to see. So this one is a increasing one as well. How about this y equals -7? What is its slope? Good, it's 0. Remember, it's really y equals 0x minus 7 is the way we would think of this. So it's got a slope of 0. What is our initial value? -7. And what's the behavior of the line? It's not rising, right? Rise over run is 0 over something. This is the horizontal one. Okay. We'll check our answers, and we got them all right. Now, if you miss 1 or 2 of these, it's not you'll still have enough points because again, all you have to get is a 70% on the quizzes. But just kind of go through. If you miss it, just take a look, and usually that'll tell you, oh yeah, that's right, because of this, that. And again, you also get a second try at it, so that's good. Okay, so this one's going to be an application problem. Let me maybe make it just a little smaller. Oh, do it this way. And before I go reading through this, I see I've got a linear equation. A lot of times they'll use other letters, but this is really y equals, in this case, b minus mx. So here's my slope, here's my initial value. And this is actually the way in business that they will usually write this equation, y equals b plus or minus mx, because it's got where you start and then how you're changing. Okay, so this equation represents a balance in your college payment account, Q quarters. So Q is how many quarters you've been in school, how many semesters. So the balance of this account is it increasing or decreasing? It's decreasing because we can see this negative slope. So look at the variable, the number in front is negative. It's going to be decreasing. And what is the rate of the decrease? That's our initial value, right? So the rate is the number in front of the variable. Now be careful, it's a negative slope, but when we say it's decreasing, we actually put a positive value in here. Because otherwise you get a double negative. So it's one of these tricky ones where if they ask for what the slope is, we would have said negative 2,900. When they're asking what's the decreasing slope, we call it 2,900. And since we called it decreasing, that takes care of the negative. And then they want units, but what is this? They don't really tell us, but we'll assume it's dollars per quarter, right? So it gets slope is dollars for each quarter. So what is the initial value? How much did we start with in our account? The number by itself, right? That's our starting value. It's nice, 23,000, that'd be okay. And how many quarters have passed at the beginning of time? 0. Good. So remember, initial value is always, it's a starting point. It's 0. So after 0 quarters, the balance in this account is 23,200. We haven't subtracted anything. We haven't had to pay for anything. Okay. So those types of questions. And again, your equation will probably be different, but questions will be very similar. How many quarters will this account pay for? Here's a key. Basically, when do we run out of money, right? We'll run out of money when we have $0 left. So now we need to solve this equation, right? When will we have $0 left? That will tell us how many quarters this will pay for. So how do we solve this? Do we deal with the multiplication first or the addition, subtraction? Two-step equation. Take a guess. Can't be too far. Do we deal with the 2,900 or the 23,200? 2,900 we would divide, right? Then we got to divide this and that. So order of operations, do we do addition, subtraction first or multiplication, division? Very good. Exactly. So SADMAT, we want to deal with the addition, subtraction. The thing is, we're subtracting here, but again, when this 2,300, since it's positive, we want to subtract 23,200 from both sides. That's 0, negative 2,320, or 23,200. This is times. Now we deal with the division. Right? So we divide by the number in front. And we're going to divide by negative 2,900 because we want that to become 1, right? And it wouldn't make sense to have negative quarters, right? So a negative divided by a negative is positive. It's 23,200 divided by 2,900. About 8. Somebody do that for us. 23,200 divided by 2,900. It's 8. So it'll pay for 8 quarters, and after 8 quarters, we're out of money. Hopefully get a job after that or something, I don't know. Hopefully graduated, we'll see, or get a scholarship. This one here? Oh, this one. Because we're talking the initial value. So initial values always means that the variable, the x variable or the input variable, in this case the q, is 0. And notice if this is 0, this whole thing becomes 0. We have 23,200. So whenever they're asking for initial value, the input variable, the x, is always 0. Last one, we ready? Okay. Good. Now this one we're going to have to get the equation of the line. Wow, we're using a lot of time. But anyway, we'll get this one. I'm going to show you a little trick on this one. And again, we may follow up on Monday if you want. There's a tool we're going to use for this. So let's first see what we're doing. And in this one, it's hard. Again, we're going to determine a linear equation. So I'd sort of look at the questions, C equals, and C could be Y equals. We're looking for a linear equation. And then we're going to answer some questions about that using that linear equation. The application problem, the word problem, says in 1990, the cost of tuition at a large Midwestern was $94 per credit hour. And then in a different year, 2004, the tuition had risen to $248 per credit hour. What they're giving us is 2 points. They're giving us in 1990, cost per credit hour is 94. That's an X and Y point. Time is usually going to be our X credit. In 2004, it's 248. So we've got 2 points. We're going to be able to come up with a linear equation with these 2 points. The thing is this part of the question here, they want the tuition in terms of X. And what is X? It's the number of years since 1990. This is a little trick we do in mathematics whenever we're using time. We'd like to have one of these points be the initial value, the starting point. So X is 0. So what we're going to do is we will subtract 1990 from each of these points. So if 1990 is the starting year, what's 1990 minus 1990? Cancels out. So we're going to look at this as the point 094. I'm not going to, so this was the initial setup, but I'm going to use the point 094. What's the year 2004? Well, 1990, 2004 minus 1990 is 14, right? 10 plus, so if you do that, that's 14 years. So the other point I'm going to look is year 14, it was 248. And so then I'm not going to use this. These are the values I'm going to use. Now we could go through our process of finding the slope, and we've got, actually we could see we've got the y-intercept there. I'm going to show you how to use a program, and I think I've got some more instructions later on, called Desmos. How many of you are familiar with the Desmos graphing calculator? Okay. I think I've got this in here. We're also going to use this when we get to lesson 4, so you'll see. We'll use this next week as well. We go to desmos.com, open the graphing calculator. So what we want to do is we want to give Desmos the points. So I'm going to click on this plus, and I'm going to ask for a table, x1, y1. So these are the points we put in. Well, remember, one of the points was 0, 94, and the other one was 14, 284. Now, what Desmos has actually done is it's put these points on the graph, but I don't see anything. And why is that? Well, my y value is only going up about to about 8, right? So what I need to do, if I go to this little gear, and this is why I record it, because when you go, you may want to watch this part of it again. Um, I need my x-axis. Well, I need to go, I'm going from 0 to 14, right? Let's go from, maybe make that, well, let's make it 20. Make it a little bit bigger. The y value, 94, I see 284. Our y value needs to go up to maybe, let's go up to 350. Again, just bigger than what the y value is. And when I've done that, then I see these little green points. And here's 094. This one here is 14,284. So I see the 2 points. It's put those in there for me. Okay. Now the next step is I'm going to ask Desmos to do I'm going to ask it to do my homework. But this is something you're going to have to do. Now, if you want some help, say on Monday, I can show you how you can actually sign into this with, say, a Gmail account, and it will remember everything you put in, or you can save it. And so you can enter this once, and then you can use it multiple times. We want to put in an expression, and what I'm going to do this first. I'm going to do y equals mx plus b, right? That's our linear equation. But I don't see any line drawn, and I'll show you we're going to change this slightly. In this table, what are my y values? Are they just y? No, they're y1. Okay, because I could do multiple tables. So I need this y, come over here, I need it to be y1. So I just put in a 1. Desmos knows to make it a subscript. Is the x is x1. So I'm going to put that in. But now it's disappeared. The thing is they're not completely equal. There's one other thing, and again, I had to find a video to figure out how to do this. I don't put equals, I put something else. It's called a tilde, and it's this little squiggly line, so approximately equal. And I'm going to do that either from here on if you're using a computer, it should be the little key that's next to your 1 or by your escape key. And notice as soon as I do that, I get Desmos to draw me the graph. Not only did it draw me the graph, it gave me the slope and the initial value here, right? It gave me my M and my B. It did all the work for me. So what I'm going to do now is I'm going to be able to answer what is the linear equation. It's going to be y equals 13.57. I'll just round it to 2 decimal places. X plus 94. So we see where got the B here, got the M here. And if you save this, because we're going to do this several times, on the exam there'll be a question like this. They'll give you 2 points and ask you to find the linear equation. Use Desmos. And again, you can even save it in there. But the key part is you need to remember this little tilde thing. I forget myself sometimes, and I have to go back, watch that video. Got one in there. And that it's not just y and x, it's y1 and y2. If you pull up a table, the next time we pull up a second table, it'll be y2 and x2. So whatever these are, we need to match it up. It's taking these points, finding the line, and then giving us what are called parameters, the m and the x, or the m and the b, right? That's what it's given us. It's not a comma, that's a point. So now we can go back, and this is what we enter into our homework. C equals 13.57 x plus 94. Now it doesn't tell us about rounding or anything. I'm going to click here. Came up with 11x. What did we? 14,248. Did I? Okay. Oh, I did 284. I'm supposed to do 248. So there's another thing. Has any of you done any computer programming? My dad used to do that. He always taught me garbage in, garbage out. I put garbage in, I got garbage out. I didn't get the right answer. Why? Because I put the wrong point in here. It's 248, not 284. So sometimes come back and say, okay, I got it wrong. Well, let me make sure I got the points right. And now as soon as I did that, oh, that's a much nicer answer. I got the right answer now because put the good stuff in, you get the good stuff out. Okay. That's what we wanted. And now we've got the right answer. And so again, but the Desmos will be the tool. So remember, this class is about learning to use tools to do the mathematics, make it easier. But we understand things. We can, okay, I got this line, how I can, and I'm going to show you how we can answer the other questions right from here. Oops. Once we get the right answer in there. And now I check it. Yes, that's the right answer. Get this out of the way. Okay, so in the year 2010, tuition will be what? Well, how do we find that? 2010, what year is that going to be? Well, remember, we're starting 1990 as year 0. So let's subtract 1990. This is asking when 20, right? 2010 minus 1990 would be the year 20. So we want to know in year 20, what is the output value? Watch what I can do here with Desmos. And I did go out to 20. I'm going to go out a little bit further. I'm going to have my x values go out to 25 so I can see this a little more clearly. What I'm going to do is I'm going to put in one more expression. I'm going to put in x equals 20. That's going to give me a vertical line when x is 20. And notice there's this intersection here. And x is 20, that's the year 2010, right? How much is tuition going to cost? $314. We just did our mathematics visually. I could have also put the 20 in for x and used the equation. Just, let me do that here. And I'll show you we get the same thing. So I could have taken this equation, c equals 11x plus 94. We were finding out what the cost is going to be when x is 20 years. 20 times 11 is 220. Yes, because I knew I needed to go out a little bit further. 220 times 94, or 220 plus 94, that's going to be 314. This point here. So we're almost 314. So we could do it either way. Last one, and then I'll let you guys go because we've used up all our time. Oops, that's the next lesson. And then the last one, in the year blank, tuition will be 347. Watch how we can do this one. 347 is a cost. It's a y equals. Come back to Desmos. We're going to add an expression. Y equals, what was it, 384? 347. Y equals 347. Notice that gives us a vertical line way up here. Again, if you don't quite see it, we could say, okay, let's make our y go up a little bit higher. Let's go to 400. And again, we just click on the intersection. Desmos is going to give it. It's 347. Oops, not that one. I want to click over here. 347 in the year 23. But what year is that? So 1990 plus 23. 9 and 2 is 11, carry the 1. It's 2013. That's what we want to put in for the answer. Yes. So that's a y value. And notice I put in y equals, and I got a horizontal line. So when they give me a y, I put a y equals, and I get that intersection. When they give me an x value, I put that in, x equals that, and I get that intersection with the line that it drew for me. And we finished our quiz. This was, well, 314, which is what we got, and this was the year 2013. Monday, come back if you'd like. That'll be our time to work through things and do this again. You're going to see we're going to use the technology and make it all work. I'm going to save the last. You got it. You got it. 5 minutes. Okay.
But I've been going back to the math because I submitted the quiz for week 2, so we're on week 3, right?
Correct.
Okay, so I submitted the quiz. I just didn't finish the homework.
No worries. You still have time for that.
Okay. All right. Just let you know.
Thank you.
Thank you.